This is Mr. Fakada. We are going to talk about in this section about work, energy, and power. So we're gonna have different success. Parts of this parts on this topic. Part 1, Part 2, Part 3, maybe. So please, before we start the discussion, don't forget to subscribe this channel so that we can have more videos that is very helpful for you guys. So let's dive in. Work, energy, and power. In physics, work, energy, and power are very related topics, related concepts, related things. In your physics, if you remember, when you define physics, even it is defined as in terms of what? Energy. Physics is something that deals with energy, matter, and the relationship between matter and energy. Now, I'm not going to tell you about energy is a capacity to do work, but it is something detailed, more than that. A physical body can possess energy due to different reasons. One is its motion. So we can have a mass, a physical mass, okay? A mass could possess energy due to different. A mass can possess energy due to its motion. So energy due to motion of some mass is called kinetic energy. So you may discuss about kinetic energy in lower grades, but here we are going to see the detail of this one. But the other one is a mass gonna possess energy due to it is what? It is different properties. So we have different reasons for a physical object to possess energy. One is a mass can possess energy due to its elastic nature. Okay, its elastic nature. A physical object can possess energy due to its elastic nature. Such energy is called elastic potential energy. Another case is a mass can possess energy due to its position with respect to the center. The kind of energy possessed by a mass due to such reason is called gravitational potential energy. So a mass can possess energy due to its position with respect to the center. Such energy is called gravitational potential energy. The other kind of energy that we are going to talk about maybe in this unit, on the other unit, is energy due to the chemical nature, right? Chemical nature of a body, which is chemical potential energy. A mass can possess energy due to its electrical nature. Electrical nature. So a mass can possess energy due to its electrical energy. The resulting energy is called electrical potential energy. Okay, so these are few of the energies possessed by a physical object due to some reasons. And there is a most important property of energy that you should note, that is energy is transferable. It is transferable, meaning it can be transferred from one body to the other. We will discuss this one in detail. The other important property of energy is it is transformable, meaning one form of energy is turned to other form. For example, electrical energy to light, maybe, or mechanical energy to heat, or heat energy to mechanical. So a kind of energy called mechanical energy is a sum of potential energy plus kinetic energy. So a kind of energy that is transferable from one object to the other object, or what that can be transformed from one form to the other form by help of forces, is called mechanical energy. So we're going to see the detail of mechanical energy later on. So this is a kind of elastic potential energy. Elastic potential energy is also called strain energy. This is energy stored by some elastic materials. Consider a rubber band. Whenever you have a rubber band or a spring, So if this is a position of the elastic material like spring, when there is no force acting on it, when you stretch the spring or the elastic material with a force, you are making some mechanical work. Work is done in physics, work is done. So the work done is equal to the change in energy. We will see later on that. So I need you guys to note a point here. The point is the amount of work done. The amount of work done is just to change the elastic potential energy of this spring. I mean, this elastic material is the same as the change in energy, because work is defined as the amount of energy changes. We will see this one in detail later. So there are two important concepts here to note. One is when work is done. In physics, when work is on done on a mass. So when work is done on a mass, for example, you can apply a force on a mass, then the force may cause a certain displacement, this S, then the work done here on this mass M to increase it is what? It's the speed. So this time the work is done on a mass, meaning when work is done on a mass, the energy of the mass, the energy of the mass will increase. The energy of the mass increases, okay, increases, and the work done is positive. A positive work is done. So when you apply a certain force F on a mass, so through this force, energy gonna transfer from the agent exerting the force to the mass. So the mass will process that energy as increasing kinetic energy. So whenever work is done on a mass, the energy of the mass will increase, a positive work will be done. Let us see how work is done by a mass. So when work is done by a mass, this is very important term. When work is done by a mass, then what would happen? So the energy of the mass will decrease, okay? The mass will decrease, okay? So let's consider this mass. Consider this mass M1. It is moving with some V1. Then it collides with mass 2, which is stationary, okay? At the beginning, the mass 2 was moving with U2, then it was stationary. Then the exchange force, during the collision, the exchange force. When these two things exchange force, when mass 1, this mass 2 was stationary at the beginning, then what would happen to mass 1? Then the speed of mass 1 will decrease. Now this is gonna have V2 after the collision. This is gonna have some V1 and V1 and so V1 is the speed of the mass 1 after the collision. V2 is the speed of the mass 2 after the collision. U1 is the speed of the mass 1 before the collision. U2 is the speed of the mass 2 before the collision. When they exchange force, this is mass 2. Then when exchange force, what would happen? Now the point to note here is the velocity of the first mass. So V1 is the speed after the collision is smaller. Yes, the rectangular mass decreases its the speed. So the speed decreases. Okay, the V decreases from where? Decreases. So the V decreases. What would happen to the kinetic energy? The kinetic energy, which is given by half mass times V square, it also decreases. So now this time work is done by mass 1 on mass 2. Now work is done on mass 2. On mass 2, work is done on mass 2, meaning the energy of mass 2 will be what? The energy of mass 2 will increase, because initially U2 was 0. Then after they collide, the mass 2 gonna have a certain V2 which is non-zero, meaning the mass 2 acquires some kinetic energy, yeah? Some kinetic energy after the exchanging of the force during the collision here. So in this process, work is done by mass 1 on mass 2. Work is done on the circular mass by what? by the rectangular mass. So work is done by the rectangular mass, the energy of the rectangular mass will decrease. Yeah, the energy of this mass will decrease because the speed decreases. The initial one is smaller than greater than, greater than, the initial one is greater than the final one for the first mass, but the initial one here. So but for the circular mass, the u2, the initial velocity, is greater than what? Greater than the final one again. Yeah, the v2. So this one, what happened to the mass 2? The mass 2 decreases. The mass 2 increases its velocity, increases its kinetic energy too. And the v2, what happened to the mass 1? The mass 1 decreases its velocity. Velocity 1 is less than u2, u1, I'm sorry, the initial velocity. The mass 1 decreases its velocity. Then what would happen to the kinetic energy? The kinetic energy also decreases. So the decrease in energy in mass 1 is exactly equal to the increase in energy by the mass 2. We will discuss this on the conservation of energy later on. But the point here is, in this case, work is done on mass 2. So the energy of mass 2 increases and the energy of mass 1 is decreasing because work is done by mass 1.